How can properties of operations be used to subtract expressions? Think about this question during the lesson. Lita's family wants to put a tiled border around their swimming pool. What expression represents the total area of the border? Begin by asking yourself, how can you use subtraction to find the area of the tiled border?
So, how can you use subtraction to find the area of the tiled border? Well, as the video will explain as well, we can take the area of the pool right there, and we can subtract it from the area of the pool and the walkway and be left with just the area of the walkway. Perfectly clear, right?
Lita made a simpler diagram of the pool. To find the area of the tiled border, we can find the area of everything, and then subtract the area of the pool, which will leave us with the area of only the border. That's what we need to find.
Exactly. So what did they say? The area of the tiles is by finding the area of the pool and the tiles and subtracting the area of the pool.
Begin by writing an expression for the area of the pool only, which is its width times its length. The width of the pool is 14 feet. The length of the pool is 2 times x plus 14 feet. Remember, your answer will be in square feet. Now let's write an expression for the area of the pool plus the tiled border. It's still width times length, but the dimensions are different. What is the length of the tiled border? Select your answer.
All right, so we're looking at the area of the tiled border, or the length of the tiled border, sorry. So if we look at, well, we know that from here to here is 2x plus 14. So we know it's not this, because that's just the length of the pool. Okay, well, there's that, and then there's another 2 feet here, boop, 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 and 2 feet here, boop, boop, boop. So total of 4 feet. So we're going to add 4. So the length of the tiled border is 2x plus 14 plus 4. 14 plus 4 are constants. They are like terms. 14 plus 4 is 18. So it's going to be this 2x plus 18.
You're looking for the dimensions of the pool and tile border. The tile border is 2 feet wide all the way around the pool. So the total length is 2 plus 2 times x plus 14 plus 2 more, which is 2 times x plus 18. Now, what's the width, including the tiled border? The width with tiled border is 2 plus 14 plus 2, or 18 feet. The area of the pool and tiled border is 18 times the quantity, 2 times x plus 18 square feet. The area of the tiled border is the difference of the two expressions. We need to use properties of operations to subtract the expressions and simplify the result. First, use the distributive property. Then, use the commutative property. Now, simplify to get the answer. The area of the tiled border is 8 times x plus 128 square feet.
All right, so if we look here, Okay, the area of the pool plus the tiles. So we found the area of the pool because it was its length. Its length, 2x plus 14, times its width, which is 14. So that's how they got here. 14 width times length. And then we had the 18 times 2x plus 18. So what he did first was he distributed, he went kind of fast. 18 times 2x is 36x. 18 times 18 is 324. Okay, then we have this negative 14 times 2x is negative 28x, and negative 14 times positive 14 is negative 196. They combined like terms, so here's our squares, here's our circles, and then we found our final answer. So they distributed, combined like terms, and then got to our final answer. So let's look at what is next. Okay, so this is a similar problem to the one we just did with the pool. I think that drawing a picture is going to be very helpful. So let's draw, here's the frame with a picture inside. So a frame holds a picture, so we're talking about the picture, that is 15 inches long and x inches wide. Okay, so the area of the picture is length times width, or 15 times x, which is 15x. Okay, and then we have the frame borders 3 inches wide around the picture. So it's, this is 3, this is 3, it doesn't look like it, this is 3, this is 3. Okay, so we went from 15, from here to here is 15, plus 3 is 18, plus 3 is 21. So we have 21 is the length of the picture frame. And then we have the width, so from here to here was x. And then we have to add 3 more on this side, so x plus 3, and then plus 3 more on this side. X plus 3 is x plus 6. So the length, the area of the picture frame is 21x plus 6. Okay, so the next thing we would have to do was to distribute this 21. So 21 times x is 21x. 21 times 6 is 126 minus 15x. Combine like terms, there's an x, 21 minus 15 is 6x plus 126. That is the area of just the picture frame. So why can you choose to add or subtract when subtracting an expression? If we were to do 21x plus 6 plus negative 15x, why can we do that? Well, because subtracting is the same as adding the opposite. That's why we can choose, as long as the terms still have the same value that they did before. As long as they're negative before, they're negative after, and etc. So that's how we would find the area of the picture frame, just like the pool. So let's go on to next example. We're going to go to example 3. So subtract the expressions. It's loading it right now. I'm going to switch to green just for fun. So we have 5j minus 2q plus 2/5 minus 4 minus 3j minus 1/2 q. Okay, when we're subtracting expressions and there's nothing to distribute, you're going to find it easier to use the other way. Instead of using the commutative and the associative properties, because the negative value is so important, it's going to be easier to distribute a 1 here and a negative 1 here. That way you don't lose those negative signs where we need them. I'm going to move my mouth off of here. So if we did that, we would have 1 times 5j times this, right? Nothing changes for that first one because that 1 is positive right here. So we still have 5j minus 2q plus 2/5. Okay, what changes is those last three because we're distributing a -1 instead of a +1. So -1 times 4 is -4. And -1 times +3 or times -3j is +3j. And -1 times -1/2 q is a +1/2 q. Okay, I would recommend doing it when you are subtracting expressions that you do distribute a -1 instead of using the commutative property, because then there's less to mess up. Okay, so we have our like terms, j, j, q, q, constants. So 5j plus 3j is 8j. -2 plus 1/2. Okay, so my answer is going to be negative because 2 has the greater absolute value and it's negative. And then 2 minus 1/2 is 1.5 j. And then we have 2/5 minus 4. Okay, so I know my answer is going to be negative because the 4 has the greatest absolute value and it's negative. And then I have 4 minus 2/5, or 4/1 minus 2/5. Okay, so 4/1, we can make that fifths by multiplying both by 5. So we have 20 minus 2 is 18/5. And 5 goes into 18 3 times with 3/5 left over. So we have j. Oh, this isn't a j. What is this? This is a q. And then we have -3 and 3/5 left over. So let's go ahead and erase this one and move on to the next one. Whoa, there's a whole bunch of stuff up there. So subtract the expressions. Write the difference. Okay, that just means write it down. Distribute the minus sign or -1 to all terms in the second expression. Okay, that's what we did. We would have skipped this step and just gone right to that second step. Combine, remove the parentheses. What we do by distributing that -1. Group like terms, simplify, right? Just like we did in the question before. The steps are the same. We did them. We managed to do them on our own. Number 3, eraser. Subtract those two. Okay, so remember, we're taking the negative sign here. We're distributing a -1 to the second one. We're distributing a 1 to the first one too, but it doesn't change anything. 17 plus 4.5 m plus 8k minus 7.5 m plus 9 minus 4k. You're essentially just changing their signs, okay? Positive, negative, positive becomes negative, positive, negative, opposites. Then we have 17 9 m k. 17 plus 9 is going to be 26. 4.5 m minus 7.5, it's going to be negative because 7.5 has the greatest absolute value. 7.5 minus 4.5, well, 7 minus 4 is 3, so we're going to have 3. And then we're going to have 8k minus 4k is going to be a positive 4k. All right, distribute that -1. That's how you make sure that these signs are all going to be correct. This is an M. Okay, distribute that -1, combine like terms, and then you get to your final answer.